All right, here we go. I think I got the audio on now. I did a whole screen recording without the audio. Anyway, chapter 4 review. Number 1, converting 56 degrees to radians. So when we convert degrees to radians, you have to multiply, whoops, this is problem 1. You got to multiply by pi over 180 degrees. The degrees will cancel. You just get 56 pi over 180. And now you simplify the 56 and 180, you can divide those both by 4. And you get 14 pi over 45 radians. Done. Okay? Number 2, you got to go the other way. You got to take 5 pi over 3 radians and convert it to degrees. So you flip this, okay? And the pi's cancel. And the 3 and the 180 can simplify to 1 and 60. And 5 times 60 is 300 degrees. Done. Okay? Question numbers 3 and 4. We got to rotate this 360 degrees to get some other angle. So you're at negative 245. If we add 360 degrees to that, whoops, we'll get one other angle. That's going to give you 115 degrees. And then if you're at negative 245 and you subtract 360, you'll be at another matching coterminal angle. You'll be at negative 605 degrees. Okay? So the second one here, though, number 4, we're not going to be able to add and subtract because it's already more than one full rotation. So we're going to subtract twice, actually. So we're at 9 pi over 4, and we have to subtract 2 pi, which is the equivalent of 360. But 2 pi is the same as 8 pi over 4. So 9 minus 8 is 1, so it's just going to be pi over 4. And we're going to subtract again to get the negative one. So we're going to take pi over 4, that one, and we're going to subtract 2 pi from it. Remember, 2 pi is the same as 8 pi over 4. 1 minus 8 is negative 7 pi over 4. So those are your answers for 3 and 4. Got to rotate a full circle, which is 360 degrees, which is the same as 2 pi. All right, next question. We're going to find some arc length. The arc length formula is arc length is equal to radius times theta. So if they give us a radius of 12 and a theta of 5 halves, all we got to do is 12 times 5 halves. And the 12 and the 2 cancel out to 6, and 6 times 5 is 30. Or no, wait, yeah, 30 feet. Sorry, I was second guessing my answer. All right, 6 asks for linear and angular speeds. Linear speed is the radius. They give us a diameter in this one at 12, but we have to turn it to a radius of 6 feet. And they give us a revolutions of 5,000 revolutions per minute. Okay, so the revolutions are 5,000, and then it's 1 minute. 1 minute, 5,000 RPMs. So to get the linear speed, we're kind of using the circumference formula to make this a straight line. That's why we have this 2 pi and the r on top, because it kind of straightens it out, makes it a line. So we got to do 6 times 5,000 times 2 pi divided by 1 minute. So it's going to be a pretty big number there on top, because 6 times 5,000 is 30,000, and 30,000 times 2 is 60,000. So 60,000 pi revolutions per minute. And that's it. Okay? Now, in angular, we don't need to include the radius. We just do revolutions times 2 pi divided by time. So angular and linear. So just notice how close to being the same they are. Linear just needs the radius. So we have to take 5,000 times 2 pi divided by 1 minute. And we're going to get 10,000 pi. Oops, one more 0. And this is going to be radians per minute. Notice this is it's in a measurement of an angle. All right, that's why we don't include the radius, because the radius makes it a linear. Okay, that's 6. Number 7, 8, 9, 10, 11, 12. This group, you're going to be answering 6 questions. You're going to be doing some right triangles and a little bit of a Pythagorean theorem at times. So for number 7, it gives us endpoint of negative 4/5 and negative 3/5. All right, the sine of theta is the y value. Okay, the sine of theta is the y value. So sine of theta is this, here's x, here's y, negative 3/5. Cosine's the x value. Cosine theta is negative 4/5. And tangent is y divided by x. So this is x, this is y divided by x. That would be negative 3/4 because the 5s would cancel, so it'd just be, it'd be negative 3 over negative 4, so it's just positive. Tangent's positive here. Now these other three, cosecant, just flip it. Flip the sign, negative 5/3. Secant, flip the cosine, negative 5/4. And tangent, you're going to do inverse of that. For cotangent, that's going to be 4/3. Done with number 7. Number 8 gives us this right triangle picture. Gives us theta right there. Gives us the opposite and the hypotenuse. So that actually is sine theta, 2/5. And you could do cosecant right away. Cosecant theta is going to be 5/2. And you got that done. But now we got to do cosine. We need to get this other leg. So we have to do 5 squared minus 2 squared. 25 minus 4 is 21. Square root of 21. Can't be simplified. So cosine theta is adjacent leg over the hypotenuse. Secant would just be the flip of that. 5 over square root of 21. Tangent is going to be 2 over square root of 21. So just use the two legs, opposite over adjacent. And cotangent is the flip of that, square root of 21 over 2. Number 9. So we got 5, negative 12. So if I draw over 5, down 12. So that'd be 5, 5, negative 12. I drew that incorrectly. I want to go 5 to the right and down 12. Let me redraw that real quick here. So I'm going to go 5 to the right and down 12. So 5, negative 12. Put my right angle. Got my right angle here. Here's my theta. So this is the point 5, negative 12. So to get sine, it's going to be negative 12 over the hypotenuse, but I got to get the hypotenuse, so I got to do 5 squared plus 12 squared. Ignore the negative there, because when you square it, you're not going to have it. 12, 5 plus 144 is 169. Square root of that is 13. So 13 is the hypotenuse here. So we're going to have sine theta. That's going to be negative 12 over 13. Cosine theta is going to be 5 over 13. Tangent theta is going to be negative 12 over 5. And let's flip them. Cosecant theta is going to be negative 13 over 12. Secant theta is going to be 13 over 5. And tangent theta is going to be negative 5/12. And we're done with number 9. So notice the Pythagorean theorem gets used in 8 and in 9. All right, 10. Number 10. Number 10, it tells us we know that the cosine theta is 5 over 11. So we could draw a right triangle that has those two values. Put theta in there. This would be 5. This would be 11. Okay? Because adjacent over hypotenuse. So we are going to need to find this missing side. So we're going to have to do 11 squared minus 5 squared because 11 is the hypotenuse. So we got to subtract. It's going to be 121 minus 25. It's going to be 96. So it's going to be the square root of 96, which actually simplifies to 4 radical 6 for that one. So now we can write our ratios. All right, sine theta. Now it does say one thing. It says that tangent is less than 0. If tangent theta is less than 0, that means one of these legs is negative. We're going to have to put a negative on the 4 radical 6. All right, so sine theta is actually going to be negative also. Negative 4 radical 6 over 11. Cosine theta is going to be 5 over 11. We already knew that. Tangent theta is going to be opposite over adjacent leg. And let's flip them. All right, cosecant theta, CSC, is equal to 11 over negative 4 radical 6. You just need one negative. It doesn't matter if it goes at the top or the bottom. Secant theta is equal to 11 over 5. And cotangent theta is equal to negative 5 over 4 radical 6. All right, very good. All right, number 11. Number 11 says that cosecant theta is equal to 2. Well, if cosecant theta is equal to 2, that means sine theta is 1/2. Now, it does say we're in quadrant 2. Quadrant 2 is negative positive, so let's use this sine theta to build a right triangle over in quadrant 2. All right, so we're going to build a right triangle over here, so it's going to be opposite over hypotenuse. this is going to be 1, and this is going to be 2. And there's our theta. So the x value is going to be negative, because in quadrant 2, all the values are negative, positive. Okay, negative, comma, positive. So we do have to do the Pythagorean theorem. So we already know this. Sine theta is equal to 1/2. Now we've got to figure out cosine theta, tangent theta, and we got to get cosecant theta. Well, we already know that's 2. Secant theta and cotangent theta. All right. So we have to do 2 squared minus 1 squared. That'd be 4 minus 1. That'd be 3. So this is square root of 3, but we are going to make it negative. So cosine is negative radical 3 over 2. So the secant is going to be negative 2 over radical 3. Tangent is going to be 1 over negative radical 3. So cotangent is going to be negative radical 3 over 1, or just negative radical 3. And number 12. Number 12. You can always pause these videos and go back and watch them again. So it says the terminal side of theta is formed by the line y equals 5/2 x. So that's the slope. So I'm going to make a graph here. And I know I'm in quadrant 3, so I'm going to be down here to the left. So it goes through 0, 0. And instead of going up 5 over 2, I'm going to go down 5 over 2. And that's going to be my build of my theta. This is the point negative 2, comma, negative 5. So this is negative 2, this is negative 5. So there's my legs. I can do 2 squared plus 5 squared to get my hypotenuse. 4 plus 25 is 29. So square root of 29 is the hypotenuse. And now I can set them up. Sine theta is equal to opposite over hypotenuse. Cosine theta adjacent over hypotenuse. So they're both negative. Tangent's going to be positive, though. Tangent's going to be 5 over 2. All right, cotangent's going to be the flip of that, 2 over 5. Secant's going to be the flip of this one, negative radical 29 over 2. And cosecant theta is going to be the flip of this one, negative radical 29 over 5. All right, that's it for the first group of questions. I'll do 13 through 28 on another video. All right, all good, all good. Oops.